Recent advances in information retrieval research from April 2025 showcase cutting-edge innovations across multiple domains. The analyzed papers focus on conversational recommendation systems, entity linking techniques, and efficiency optimization methods. Key themes include improving system reliability, enhancing scalability, and addressing fairness concerns in retrieval systems. Notably, interdisciplinary approaches have emerged, incorporating concepts from economics to clinical evaluation frameworks. These developments represent significant progress in the field of computer science information retrieval. Computer science information retrieval, known as carbon monosulfide (IR), specializes in developing systems for efficient information storage, search, and retrieval from large datasets. This field powers applications like search engines, recommender systems, and multimodal retrieval platforms, utilizing machine learning, natural language processing, and knowledge graphs. The April 2025 research papers particularly emphasize three focus areas: conversational recommendation systems, novel evaluation frameworks, and techniques for efficiency optimization. These advancements demonstrate the field's ongoing evolution and practical applications. A prominent research theme involves conversational and zero-shot recommendation systems addressing data scarcity challenges. Sarana and colleagues proposed an active learning framework that synthesizes conversational training data for LLM-based recommenders. Simultaneously, Choi's team developed Link, a hybrid linear neural model that effectively balances speed and accuracy in session-based recommendations. These innovations are particularly significant as they enable the generation of training data without requiring costly human annotations, opening new possibilities for low-resource domains. Evaluation frameworks for ensuring system reliability represent another critical research theme. Gupta's team introduced MedCode, a critique-based disagreement evaluation method specifically designed for medical large language models. Meanwhile, Pradeep and colleagues automated nugget extraction processes to improve retrieval augmented generation evaluation. The most notable breakthrough in this area involves quantifying and reducing hallucination risks in clinical settings, enhancing the trustworthiness of medical AI applications. Multimodal and knowledge-enhanced retrieval systems have seen substantial advancements. Kim's research team developed KGMEL, which integrates knowledge graphs with vision language models, achieving a 5% improvement in F1 scores for entity linking tasks. The EREL at MIR workshop organized by Fu's group addressed efficiency challenges in multimodal representation learning. A key technical innovation involves creating joint embedding spaces that better align entity mentions with their representations across different modalities. Significant breakthroughs in efficiency optimization and fairness have emerged. Huang's Colbert Serve system dramatically reduces RAM usage by 90% through innovative memory-mapped architectures. Shen's work on L-sparsification achieves comparable performance to traditional models while requiring 10 times fewer floating-point operations. Shu's team introduced elastic rank, framing fairness constraints through economic elasticity concepts, providing new insights into balancing equity and utility in ranking systems. Key findings from April 2025's research papers reveal several impactful contributions. Synthetic data generation techniques enable conversational recommender systems in low-resource domains. The MedCode framework significantly reduces hallucination risks in clinical applications. KGMEL sets new benchmarks for multimodal entity linking through knowledge graph integration. Colbert Serve achieves remarkable latency reductions, while novel economic models provide fresh perspectives on fairness-accuracy trade-offs in ranking systems. Methodological innovations driving recent progress include active learning approaches that generate dialogues from non-conversational data seeds. Contrastive learning techniques have proven effective for entity mention alignment in systems like KGMEL and Link. Memory optimization strategies, particularly disk-based retrieval methods, have enabled more efficient systems. The application of L-regularization has facilitated inference-free sparse retrieval, while economic analogies offer new ways to conceptualize fairness constraints in ranking algorithms. Among the seminal contributions, Sarana's work on zero-shot conversational data synthesis stands out. Addressing the critical challenge of domain-specific training data scarcity, Their active learning framework leverages large language models to generate synthetic dialogues. This innovation enables the deployment of conversational recommender systems without the prohibitive costs of human annotation. The technical approach involves transforming existing review data into conversational formats through carefully designed generation processes. Kim's KGMEL represents another landmark contribution, tackling limitations in vision-language entity linking. By fusing knowledge graph triples with multimodal embeddings, the system achieves superior performance in entity linking tasks. The 5% improvement in F1 scores over previous state-of-the-art systems demonstrates the value of incorporating structured knowledge. The technical innovation lies in creating a joint embedding space that effectively aligns knowledge graph entities with their multimodal representations. Huang's Colbert Serve system addresses the critical challenge of high memory usage in dense retrieval systems. The solution employs multi-stage scoring with disk-based indexes, significantly reducing hardware requirements. The system achieves a 90% reduction in RAM usage while improving latency by 60%. This breakthrough enables the deployment of sophisticated retrieval systems on more modest hardware configurations through innovative memory mapping techniques for efficient index retrieval. Future directions in computer science information retrieval point to several important challenges and opportunities. The field requires standardized benchmarks, particularly for evaluating system efficiency. Deeper analyses of fairness-accuracy trade-offs will build on current economic-inspired frameworks. Knowledge graph augmentation and inference-free retrieval methods are emerging as promising approaches. Interdisciplinary methods continue to gain traction, while sustainable deployment strategies remain crucial for real-world applications. 3 key takeaways summarize April 2025's research landscape in carbon monosulfide IR. First, data efficiency techniques like synthetic data generation and sparsification enable deployment in resource-constrained environments. Second, reliability improvements through critique-based evaluation methods reduce risks in critical applications like healthcare. Third, memory optimization breakthroughs redefine the possibilities for dense retrieval systems. As the field progresses, balancing innovation with ethical and computational constraints will remain a central challenge. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from the ArXiv preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode,